All right, today we're jumping into a really fascinating research paper about a technology called DeepSeek OCR, and it introduces a completely radical way for AIs to read and remember huge amounts of information. Honestly, it's a wild idea that could completely flip how we think about AI memory on its head. So, let's start with a kind of wild thought experiment. What if you wanted an AI to read, say, an entire library? Now, instead of feeding it all that digital text, what if you could just turn the whole thing into a giant photo album and have the AI look at the pictures of the pages? That's the big idea we're digging into today. What if you could solve a text problem by turning it into a picture problem? Now, to really get why this is such a game changer, we first have to talk about a huge problem that pretty much every AI today is wrestling with. It's a fundamental issue with their memory. You know how you can't just copy paste an entire novel into a chatbot and say, hey, tell me about the main character's motivations? Well, there's a really good, very technical reason for that, and honestly, it's one of the biggest roadblocks in AI right now. And that reason is something called quadratic scaling. It sounds complicated, but the idea is simple, and it's a real killer. For every chunk of text you add, the cost to process it doesn't just go up a little, it skyrockets. So you double the text, you quadruple the compute cost. You can see how that gets out of hand fast. This right here is a perfect way to think about it. An AI trying to read a long document is like you at a huge networking event. Following one conversation, easy, but trying to track every single conversation happening in the room at the same time and how they all relate to each other, yeah, that's pretty much impossible. That's the exact headache AIs are dealing with. So, if just throwing more text at the problem is a dead end, the researchers behind DeepSeek OCR came up with a totally different angle. They asked a brilliant question. What if we just stop giving it text altogether? And this is it. This is the big idea. Instead of feeding the AI a stream of digital words, what if you just take a picture of the page, like literally render it as an image, and then tell the AI, here, read this picture? It sounds almost backward, right? But it's a clever way to completely sidestep that whole text processing mess. The name they gave this is optical compression. And here's the magic trick. A single picture can hold a ton of text, but to an AI, that picture can be boiled down to just a handful of data points, what they call vision tokens. So you're essentially smuggling all that text past the AI's big computational guard dog. And look at this comparison. It really shows you the payoff. On the left, a normal page of text might cost the AI, say, 1,000 text tokens to process. But on the right, you turn that exact same page into an image, and suddenly the AI only needs around 100 vision tokens to get the same information. That is a 10-to-1 reduction. It's huge. Okay, so this sounds great in theory, but how does it actually work in practice? This isn't just some concept on a whiteboard. The researchers actually built a model to pull this off. The whole system is basically a two-part machine. First up is the DeepEncoder. Think of this as the genius that looks at the picture of the text and just squishes all that info down into a few of those tiny vision tokens. Then you've got the decoder, which takes those few tokens and, like a magician, perfectly rebuilds the original text. It's this incredible compression and decompression engine. The DeepEncoder is really where the magic happens. The paper explains that it's got this really clever process. It kind of glances at the whole image first to get the big picture, the layout, the paragraphs. Then it zooms way in to see the super fine details of each letter. After that, it combines those two views and uses this seriously powerful compressor to shrink it all down without losing the important bits. All right, now for the part we've all been waiting for, the results. Did it actually work? Let's check out the numbers. The main number here is just, wow, 97%. DeepSeek OCR can take those super compressed images and reconstruct the text with 97% accuracy. I mean, that is practically perfect. And get this, it's hitting that 97% accuracy while compressing the data by a factor of 10. So the original text took 10 times more data to represent than the final compressed image. That's the insane efficiency we were talking about, right there in black and white. But they didn't stop there. They really pushed it. At 15 times compression, it's still pulling 86% accuracy, which is amazing. Even at a crazy 20 times compression, it's holding on at 60%. And what that tells you is really important. The model degrades gracefully. It doesn't just hit a wall and break. It just gets a little fuzzier, which is what you want to see. This chart really drives the point home. Look at other powerful models. They need almost 7,000 vision tokens to process a document image. And then look at DeepSeek OCR, less than 800. It's not just a little better, it's in a completely different league. It's getting these world-class results using a tiny fraction of the horsepower. And hey, don't just take my word for it. This quote from the paper says it all. The researchers themselves point out that their model is achieving state-of-the-art performance while using the fewest vision tokens out there. They're basically saying, we're the best and we're the most efficient. So, what does all this really mean? Where does this go from here? Because this is where the whole thing shifts from just a cool tech demo to something that could seriously change the future of AI. Look, this isn't just about making a faster document reader. This is a potential blueprint for what's called ultra-long context, AIs that can remember massive amounts of information. But even cooler than that, it might allow us to build AIs that mimic a really key part of how we think. And that human-like trait? It's forgetting. I know, it sounds weird, but the paper proposes this incredible forgetting mechanism. Imagine an AI that stores its brand new memories as super high-resolution, crystal-clear images. But as those memories get older and less important, the AI could just downsize the image, make it blurrier, which also makes it way, way cheaper to store and remember. This timeline shows you exactly how it would play out. A conversation you had an hour ago, that's a tack-sharp image with a high cost. Something from yesterday? Still clear, but smaller. A month ago? It's getting blurry, taking up very little space. And a memory from a year ago? It's just a faint impression, costing next to nothing to keep around. This is so much like how our own brains work, right? We prioritize what's new and let the old stuff fade. And the end game here is an AI that could have a sustainable, long-term memory. It wouldn't need to hold on to a perfect, flawless recording of everything forever, which is computationally impossible. Instead, it could strike this beautiful balance between having deep, useful context and the practical reality of not having infinite computing power. Which brings us to this final massive question. Could this whole idea, turning words into pictures and letting old pictures fade, be the secret to giving AI a memory that is, for all practical purposes, unlimited? It's a pretty mind-bending thought, isn't it? Thanks for diving into this with me.